So number 3, grandparents are investing in a college fund for their newborn granddaughter. How nice. Their goal is to have an account that will pay $15,000 quarterly for 4 years. If the grandparents can, so that's probably like they're wanting to pay $15,000 toward this young woman's college expenses every quarter in college. So if the grandparents can invest 8% compounded quarterly, how much do they need to invest at the end of each 3-month period for the next 18 years in order to begin drawing $15,000 from the account in March of the 19th year? And so we know that we want payments to be coming out of this account. And so we're going to need to work backwards to figure out how much they need to pay into it. And so we're going to be drawing $15,000 from the account. The value is going to be going down, so this is going to be a present value of annuity. The rate is 8%. It happens 4 times a year. And they want to withdraw for 4 years. So again, when we do problems like this, we need to work backwards. We need to start from the time that the money is being taken out of the account, figure out how much money needs to be in the account to make that happen, and then do the future value scene to figure out how much the size of the payments needs to be to reach that amount in the account. And so I is R over M, so 0.08 over 4. I think that's going to be 0.02. I'm just going to use my calculator to check, because sometimes I make goofy mistakes if I try to do math in my head. Yep, and then MT is going to be 4 times 4, so that's going to be 16. And so we need to know how much money needs to be in the account to make this happen. And you might be thinking to yourself, well, gee, why don't I just multiply 15,000 by 16, which would be 240,000. And we're going to see that we don't need that much in the account, because as we take money out of the account, what remains grows. And so this is a good way to make our money work for us. And so S equals R times future value. No, this is going to be present value. So 1 minus 1 plus I to the negative n over I. And we've got S is equal to 15,000 bucks times 1 minus 1 plus 0.02 to the negative 16 over 0.02. And that's not the right formula. Should I go get the right formula? Okay. So present value of annuity is what we got here. And so we need to be able to withdraw 15,000 every 3 months. I is 0.02. N is 16. And that's where we go. So we are going to need $203,000 in the account. So S equals 203,665.64. And so now that we know how much needs to be in the account, so let's write that down. They need 203,665.64 in the account. And then, as I mentioned a moment ago, I think total withdrawals is going to be $240,000 to withdraw 240 grand total. So I just threw that on there to demonstrate that as the money stays in there after they stop contributing and they start taking it out slowly, it continues to grow to the tune of about $36,000. So they get 36,000 bucks for not taking this thing out all at once, but by taking it out in payments of $15,000. And so we need to figure out what the quarterly contributions need to be to the account to reach that value. And so we're going to have a future value of annuity now. because the value in the account is going to be going up. And so we need a total amount of 203,665.64. We don't know how much the payment's going to be. The rate is going to be the same, 0.08. It's still going to be done, these payments are going to be made to the account quarterly, and they have, I think it's 18 years to do this. Is that correct? Yep, newborn granddaughter, they want the money in there after her 18th birthday. So 18 years in there. So 0.08 over 4 is going to be 2, 0.02. MT is going to be 4 times 18. And so 72. Just going to verify that on a calculator really quick. Yep. And so what we got, now we need the future value formula. So S equals R times 1 plus I to the power of n minus 1 over I. Again, now because the value in this account is going to be growing, and we're trying to figure out how much the payments need to be to get to the amount that we want. So future value of annuity goes right there. And we need a total value of 203,665.64. Looking for the monthly payment, or the quarterly payment amount in this case, and that's going to be 0.02. N is going to be 72. And again, I is 0.02. Should get those numbers in my formula on paper as well. So 203,665.64 equals, we don't know what the payment's going to be, times 1 plus 0.02 to the power of 72 minus 1 over 0.02. And we got to divide by 158,057. Got my division sign again. So we got $1,288 and 56 cents. So the quarterly payments must be $1,288.56. Now, I don't know if I asked this in the problem yet, but I'm going to ask it. And I'm going to augment the problem to add this question in here. So they need to pay that much every quarter for 18 years. And so total deposits, I'm just curious about this, total deposits are going to be 1,288.56 times 4 times a year times 18 years. So total deposits are going to be $92,700 and let's rearrange this a little bit. I'll be right back. I'm going to rearrange this. So total deposits are going to be $92,776.32. The total amount that they're going to take out is going to be $240,000. And so the growth is about $147,000. And so that's pretty awesome. So these people made $147,000 on this investment, basically for just shoveling some money away and saving it for their granddaughter's college expenses. And again, this last piece, I'm going to change the number 3 so that when you get it, it asks those questions, because those are good questions. $147,000 for doing nothing is pretty good.